Hey everybody, my name is Mitch Lathrop. I'm a director of virtual production at Fuse Technical Group. Um, my background is kind of more in the video engineering side of things. Started out in at the Walt Disney Company doing some nighttime spectaculars and projection mapping, and then on to concert touring and corporate events, where we have kind of worked together throughout the years at different companies and parts of our lives. So I'm kind of talking about from the video engineering side of the virtual production.
I'm Jared LeClaire. I've worked in a number of capacities across broadcast, film, TV, live concerts, whatever. Usually where I've come in is kind of connecting content and engineering pipelines together.
I got my own. I'm Andrew, Director of Technology for Fuse Technical Group, and other than making sure that everyone here knows math, I also oversee software development efforts and technical strategy.
So what we want to talk about today is how the virtual production the brain bar or virtual production volume operations bar works, right? How do we control and marshal the resources of all this equipment that delivers the pixels to the screen, and in a way that the operators can effectively control and we keep up with the pace or the speed that that filmmaking needs to run at. So we kind of, on our background here, we have kind of a timeline of where we started. So we're going to talk about some of these productions and like little vignette sections and kind of some of the challenges and kind of trying to illustrate out the journey that that we've kind of gone on to kind of make all this stuff work. So back in 2017, we were working on Murder on the Orient Express. As far as we know, this was the largest LED volume that was built for this type of a purpose. We built a curved bottom LED volume with end caps so we could move different train cars in and out. And this was very challenging at the time because the computers that we used to operate this and the LED processors were just coming out. This was all cutting edge. The specs on these computers said that they could do quad 4K outputs, and we found out that was a little bit of a challenge. So we were kind of had stacks of equipment. This is the cleanest that rack ever looked. That's what it looked like when we started. Towards the end, it was completely torn apart, cables, we had back planes off, and we were really trying to get the most out of the computers and the hardware needed to make all this happen. And so our approach kind of has been from the concert tours and live events and exhibits where we're doing giant image magnification. We're doing things like Coachella or other projects where it's massive video screens and we're kind of more on the broadcast side of things, delivering pixels to the screens. And that's all the virtual production stuff is it's like not a one-size-fits-all solution, right? Every one of these projects we're going to talk about, we're all custom cut up into different sections, and we borrowed things from broadcast when it comes to like sync. We'll talk about screens management. How do we deliver all these pixels up to the final LED volume, but make it so that the operators can have an idea of what they're doing. Some of these are the equivalent of 24 or 30 4K outputs at one time, and we can't have a digital replica of 40 4K outputs so that the operations team and the content team can see what they're working on. So we've kind of been at the cutting edge of a lot of this stuff as we've gone through, where it's like, hey, this says on the box that it can do this, and so we go running into it and then realize, actually, we're going to have to talk to the manufacturers and say, hey, this is really not exactly what, it's not out of the box working. So I'm going to pass it off to Jared. We're going to do a talk about First Man and how we kind of pivoted from these initial projects to the next evolution.
Yeah, so for this project, it was kind of pivoted into the, what is now sort of the ubiquitous format of an LED volume, right? It's a curved wall. So we had a number of problems to solve and ended up going with a custom solution for most of the playback. And as you can see in this picture down here in the lower right, is the scale started to explode. And that's kind of the trend that we started to notice, is that as the scale increased in these projects, along with it did the engineering complexity, the content complexity, and everything else. And so we had to develop a number of custom solutions to kind of band-aid those challenges in order to pull this thing off and uphold the creative vision of the filmmakers. So it was about 3 months of solid production, and ended up coming to it was a long road, but ended up coming to a rather reliable system, and also set up a lot of the paradigms that we still operate in today, such as the remote server rooms, remote control desks, things like that.
Yeah. Kind of some of the evolution of this is we needed maximum flexibility as we were going through these projects. So, as this was all unfolding, we were talking to other industry experts, and they, from some people's opinion was, oh, you guys need a full-on machine room. This has to be done in a data center mentality, right? But data centers are built for maximum hardware packed into a small space and not really flexible. Where with what we're doing here, there's so much evolution, and we're pulling the back planes off the computers, we're replacing components, really getting into a worst case scenario sometimes situation of trying to make all this stuff work, and it can't be all packed into a tightly packaged up form factor. This project was Westworld in 2019. This was kind of an interesting era because this is when everything that we've talked about up until this point was plate playback, where media servers were playing back rendered content and image sequences or other formats, so that we were recreating stuff that had already been captured for the most part, right? And then this production was kind of bringing in the video game Unreal Engine aspect of things. And so this was kind of a unique challenge because we were taking the computers, plugging them directly into the LED processors, and we needed to rotate the outputs 90 degrees to make this project work. And as you can see here, we were having the UIs turn 90 degrees, and there wasn't really an easy to manage out-of-the-box solution. And so all the developers are turning their heads sideways, trying to solve some complex problems, and that wasn't really ideal. So over the weekend, we kind of brought a bunch of new gear in, retooled the system so that we could have a more unified experience for the operators and the engineers and the content team. So we kind of have come at this several approaches, and it's like we would get the solution to be in a really good location with one method, and then we do a little bit of a pivot, and so going after more video game development techniques. So the projects that we, what was it, 2019, we kind of got into a good position where we kind of had known basically where we're at today. I think those were the early days of where we were at, right? And so now we kind of knew all the different things that we were going to need to the challenge we were going to need to face, and we started being able to perfect that and move forward. And then this kind of brings us into the area of the Mandalorian season 2. We went and kind of took what they had done on season 1 and rolled that into a more robust and long-term volume project. You can kind of see here in the bottom corner, this is a floating server room where we were building out several equipment racks in more of a structure that kind of looks more like what a data center would be. This was a pretty heavy challenge, right? It was a lot of gear showing up at the last minute, and we were packing into a very small space, and we knew that the expectations were going to be very high, that this needed to be scalable, changeable, and we were going to have to deal with a lot of stuff on the fly. So this, we really pushed forward in this project here, and there's not quite as many pictures of the server room because it was quite messy, but the next push forward that we did on this was Thor: Love and Thunder, which was a project that we worked on in Australia. And for this, we built all the server rooms here in California. We packaged them up on server in shipping containers and moved them and reassembled them there into a temporary setup. As you can see here, quite a lot of pixels to be delivered to the screens. We had to build out, our server rooms got a lot, these are much better pictures to refer to than some of our early iterations. But things started to get dialed in. We had kind of a workflow of how do we get the video signals from the computers into the screens management and routing, and then from there to the LED processors, and then from the LED processors that are in a cooled environment, how do we get this stuff out into the volume to deliver the pixels to all these processors, or to the LED tiles from the processors. So let's go ahead and go to the next slide here. Another thing we want to talk about is when we do these deployments, we need to be able to not only deliver the server rooms in a rapid form factor, we need to also have a system set up for the operators so that they have desks where this equipment can be rolled out, it can be plugged in with power and connectivity, and for us to kind of think about the big picture of how the operations happen, right? So this is a photo of our some of these desks that we manufacture in-house. We have CNC machines at Fuse and a really talented team of people that we kind of look at the overall problems and challenges that we have to face in virtual production. And we were manufacture these desks with KVM systems to make it easy for the operators to jump which computers they're on and for us to see color accurate displays of what the content is. And so additionally with this, we had to figure out how we were going to get the server rooms in buildings where we couldn't do a long-term volume. So this is a rendering here that Kobe and our team put together. We deployed a server room in a shipping container. So we built all this again in our area in Los Angeles, and then shipped this and dropped it right outside of the stage, and ran fiber and power. And we're able to get this LED volume up. We're talking on the scale like getting a month to build the LED volume in the machine room, and we were able to get this down to around 2 weeks with these rapid deployment systems. You can kind of see here we modified our existing racks that were on casters onto sliding rails, so we're able to move the racks forward and backward and maintain HVAC and cooling to keep all these servers cool and operating at good temperatures.
Yeah, so all right, yeah, so the through line kind of in our approach throughout the years is just a constant process of iteration, trying to improve from project to project, trying to get, smooth out the wrinkles, but also stay on top of the curve of technology, which is ever changing, as we know. So it's sort of a never-ending battle, but it's also what's necessary in order to continue pushing this aspect of the art form forward. But now being at a point where all these innovations have taken place, and you kind of get to a place where you're reinventing the wheel on every project, and it's exhausting. So now are focusing on some development efforts that can act as through lines through all the projects. And so I'll hand it over to Andrew here to discuss that.
Cool. Thanks, Jared. Okay, so one thing I really want to point out about this stuff, a little recap, like as they've been reviewing the challenges about, that they've dealt with over the last few years, you'll notice these stages have continued to get bigger. And while you can kind of scale that hardware linearly, because all of the hardware depends on each other, the problems scale exponentially. So in order to deal with that environment, we need to create a solution that is very flexible, adaptable, and distributed. So this, what I'm about to show you, is not the solution for everything here, but it does cover a significant amount of what we've been dealing with, and it's one of many solutions that we're pursuing. So, great. This is called Stage Manager. It is ultimately a software application which runs on multiple platforms. Before I get into that, let's take a look at the problem space that this is addressing in the context of the greater challenges that Mitch and Jared have just covered. So one of the striking things that we discovered on Thor, we went through all of the hardware on set and calculated how many different parameters we had to keep track of. Came up with more than 15,000, which is an astonishing number. And if any one of those is off, that may result in an immediate issue that you're aware of that you can then go correct, or it might be something that you don't find out until sometime later, like in post. And so because of all of those things, this whole process is error prone. The feedback's delayed. Sometimes the information that is reported to you by the interface that is meant by the vendor to control any one of these pieces of equipment is actually lying to you. And we've seen that happen, in things as critical as the NVIDIA control panel. So, this is what we're trying to deal with this solution that I'm going to show you here. You want to cycle? Great. Cool. So our solution here is meant to be unified. We're trying to take all of the equipment, certainly anything of the same type, and reduce it to a single control interface that can control that same parameter across any number of those devices of that type. We're also going horizontally with it, where you can control the same type of parameter across different types of devices. A good example of this is frame rate. So when you try to change frame rate on a virtual production set, that currently requires multiple engineers going to their unit of specialty and changing the frame rate on each of those pieces of equipment throughout the entire stack. It's pretty challenging, it's error prone, and it takes a lot longer than it should. It's something that sounds like it's very simple to someone who's not working on this side of it, just like, hey, why don't you just go click the button, change the frame rate? But no, it's in 50 different places, and not all of them stick. The other thing is we don't know when stuff changed necessarily. It's something that we'd like to do is be able to take snapshots of the entire system state at once, to be able to revert back, compare between when we did a shoot on this day, did all the parameters match a shot on the other day. We also want everyone to be able to use it. Right now, this is all very obscured behind a team of very specialized people, and to be clear, that's not going away. We still need those people to engineer these systems, but we're hoping that we can make the control of these systems much easier. And finally, maintenance. One of the things that Mitch pointed out earlier regarding data centers is that it's really clean to build a data center. You can get great density and great performance power out of it, but it's not very flexible when you need to go and change something out that you didn't expect when it was designed. And so we're trying to reflect that in the software that we build as well, and understand that whatever the configuration of the software is at the very beginning of the shoot is not going to be what it is at the end. And so making those changes needs to be painless and effective. So now I'm going to show you what this thing actually looks like right now. So you'll probably notice immediately that the center is very colorful and similar to some other control interfaces that you might have seen. That is intentional. We want this to be familiar, but we also want to enhance it beyond what those other similar interfaces are able to do. So one of the ways that we've started by doing that is this devices screen here, you can tell, is actively checking to see if the device is even accessible. And so you see all those request timed out errors. That means the device is offline. And we have that working across a bunch of different kinds of devices. You can see routers here, KVM units, the rendering systems themselves, screens management. So we're trying to cover the whole pipeline. On your right here, you see this macro editor page. This is really fun. It's as you're building this stuff out, these control macros, you can actually test each step individually and get the response right there immediately to know that what you're doing, what you think that you're doing in there is actually what's going to happen when you run it. So this makes it very easy to debug and to build out these controls. All right, want to switch to the next one? Cool. There's also auditing built into this. When anyone executes an action, we know who did it and what the result of it was. And so you can see there's a log of things from our stage 1 in Glendale, and some of them are green, which means they succeeded. Some of them are red, which means that they didn't. But that's not really the whole story. It's important to know why something didn't succeed, especially when it's on you to go and troubleshoot it. And so that's why, for any of these, you can click on them and dig into the log and see very specifically that the reason why this step failed is because that Brompton processor is what is called stacked. And stacked is really interesting. It's a new feature of theirs that lets one processor control the rest of the stack. So in this case, based on this additional information, I can tell that when the operator issued this command, it actually did work because it hit the master, and the master relayed to the stacks, and the stacks ignored the following request from this application. That, in this case, was intended behavior. But if all we did was just throw an error every time you ran a macro, this would be very opaque. We'd be running around trying to figure out why did the screen behave the way that we wanted it to, but the app did not. And any time that you have a divergence like that, it reduces the trust in your application. So we're trying to provide as much visibility into the way that this works under the hood as we possibly can, so that we help the users troubleshoot quickly, but they also trust that what the app is telling them is actually the most correct version of any feedback that they can get in the system. So this is something that is currently in beta. It's private beta right now. We're using it internally on multiple stages, and it has become a critical component of several of them. So we're approaching a time where we can open this up to other people to start using and exploring and giving us feedback on. And so if you go to the next slide, here's a QR code where you can sign up for this application. Thank you, guys.
Yeah, I think, so what we just kind of want to illustrate with this and drive home is that over the years when we've been doing these projects, they've increased in complexity and the amount of equipment that's required to make this stuff happen. And especially given during the pandemic, where we had supply chain issues and you know, we build these really complex systems, and we can't always guarantee that this particular piece of equipment is going to be the exact same that we use time and time and again, right? And also, it's just changing. We've been at this for several years. There's new products that come out all the time, or new features that we need to support. And so we're really focused on trying to make a user experience for virtual production operators that is consistent. And you know, we talked to, as this has scaled up, the amount of time that we are given on set to achieve these tasks or marshal these resources, that is not scaling up for the most part. We have minutes to respond to things, right? And especially, it was kind of staggering when we really went through the development. We're like, there's 16,000 parameters of things that could possibly go wrong right now. And there's just simply not time to be able to go through each of those individually. It's really been kind of a challenge as we've been dealing with this stuff over the years, is that this requires like a level of dedication and like custom resource. You know, when you build an app, the business case of that, you want to get it out as far as you can, as far right reaching, but we have such a small niche, but it was still so necessary that it was done. So we've kind of been, this has been a passion project of ours for a long time. It's been pretty crazy. We've got to do some great stuff, but it's really great to kind of see this come to fruition. We have a great support team at the office and over at Fuse, and it's really great to work with the LED team and the content teams and figure out how we can really come together and build tools to make this a reliable experience. It's certainly a challenge, I think, on virtual production sets, right? Keeping everything in line together. Yeah, does anybody have any questions or want to ask us anything about this?
Hey guys, so that's a really interesting tool. I would love to hear a little bit more about how it's deployed between all your systems.
Yeah, sure, thanks. Currently, it is a standalone application that can run on Mac, Windows, Linux, iOS, Android. So you can just get the executable, install it there, or the app, download. Right now, it is synchronized to a cloud database as far as the configuration. So once you have created a stage and joined your other users there, everyone will see the same configuration and controls that any of you create. Right now, when requests are made, they're made from the device that is running the application directly to the device that you are controlling. But one of the things that is upcoming is to have a central server that can relay those commands so that monitoring and scheduled commands can happen even when, you know, all the front-end devices are offline. So eventually it will be distributed in that way, but currently it's just each standalone device operating on its own, doing its own control, but sharing configuration data. Mm-hmm.
Anyone else out there? No? All right, well, I guess you guys can individually grab them if you want to and talk to them. Thank you guys, and again, appreciate your help on this booth so much. You guys are amazing.